And now it's time for science again. We have the other half of our mixtures and solutions presentation or lesson here. We did half yesterday, we'll do the other half today. I'm going to start this one again by showing our two big picture vocabulary terms here. Our first one being mixture. A mixture is a combination of two or more substances in which each keeps its own properties and both can be easily separated. You should be familiar with the example in the picture here. I've talked about it a lot in class. I like this one because it's easy to see that these beans are mixed together, right? But this is just a mixture because they are different sizes, shapes, there's different kinds of beans. We could easily separate those again if we wanted to. A solution, however, is also a type of mixture, but it's a specific mixture, a liquid mixture, in which one substance is mixed evenly throughout another substance or something else is dissolved in a liquid. For example, salt in water or sugar in water, if you stir it up enough, it does dissolve evenly in that liquid. So let's keep talking about mixtures and solutions. A little more background information here. When ice melts, it changes to water. We all know that. Sugar and salt can also melt if they get very hot. When they do, they become clear like water. When sugar and salt dissolve, they form clear solutions. Does this mean that melting is the same as dissolving? Not at all. Melting is what is called a change of state. Solid, liquid, and gas are the three different states of matter. Melting is a change from a solid state to a liquid state. And melting does not form a solution because only one material is there. Salt water and sugar water are mixtures because two materials are being mixed. And we don't mean a mixture like the example of the beans where they can be easily separated. Remember, a solution like salt water or sugar water is a type of mixture. It's a specific kind though. Just because everything ends up as a liquid does not mean that anything has melted. So how can materials in a mixture or solution be separated? Some mixtures can be separated by physical processes. A physical process uses the physical properties of matter to separate a mixture. For example, you could separate a mixture of sand and rocks with a strainer. The sand will fall through the tiny holes and the rocks will stay in the strainer. A strainer wouldn't separate a mixture of sawdust and sand because sawdust particles and sand particles are about the same size. To separate this mixture, you would dump it into a bucket of water. The sand would sink and the sawdust would float. Now think about sand mixed in water. How could you separate those items? Perhaps you could use a filter. A filter can separate a mixture of small bits like sand in a liquid. The paper in a filter has very small holes that let water pass through, but not solid particles like sand. How about metal items? There are tools that can help us separate those items too. A magnet can help us separate some types of mixtures. Magnets attract anything made of iron. You could use a magnet to separate pins from toothpicks, for example. What happens when water or a water solution is exposed to air? A water solution is water with something dissolved in it, by the way. Water molecules leave the liquid and move into the air as a gas. This process is called evaporation. As water evaporates, the dissolved material is left behind. Solutions are usually separated by evaporation. Warming the liquid speeds up the evaporation process. If a solution of salt water or sugar water were allowed to completely evaporate, the salt or sugar would be visible at the bottom of the container. The salt and sugar particles would look much as they did before they were dissolved. All the processes mentioned above are physical processes. The other kind of process is a chemical process. In a chemical process, a new material is formed. For example, hydrogen and oxygen are two pure gases that combine to form water. The water is not a mixture though. It is a new material that is different from the beginning ingredients. Those molecules have chemically bonded together. The water can be separated into hydrogen and oxygen, but not by any physical process. So, looking to the future, drinking the ocean. Water, water everywhere, nor any drop to drink. This is a line from a famous poem about sailors on a ship in the middle of the ocean who run out of water to drink. The sailors are surrounded by water, but they can't drink it because ocean water is salt water. More and more people have a problem just like the sailors. Fresh water on Earth is running out. Some countries near the ocean have started to separate ocean water into salt and pure water to drink and water their crops. Separating salt from seawater is called desalination. We already learned that this can be done by evaporation, but we don't need to lose the evaporated water to the air. It can be recaptured as liquid water and repurposed as drinking water or watering crops, like they mentioned. When you desalinate water using evaporation, you need a lot of heat. Producing heat is expensive, takes energy. Most desalination happens in countries that have three things in common. They don't get much rain, they are near the ocean, and they have a lot of fuel to make heat. It is important to find better, cheaper ways to desalinate water if we are going to solve Earth's freshwater shortage. Scientists are working hard to make evaporation cheaper and to find ways other than evaporation to remove salt from seawater. So, what do you think? Why is the ocean salty but rivers are not? Think about how water moves on Earth. The land contains many compounds, including salts. Rivers run over land to the sea. Water evaporates into the air where it forms clouds. Rain falls from the clouds and runs into the rivers.